Today's subject is clusters. Because automating is a radically different model, and the future requires us to rethink the existing models that we have, clusters are an important concept in understanding how to best deploy automating, and also how well it integrates with communities, and even how it supports resilience. Automated clusters are tight-knit combinations of a mechanical recycling facility and its army of 3D printers. Together, they create one unit of circularity. In essence, the ability for a community to take its own waste and make stuff from it, make products from it. And these provide a much lower carbon, lower cost opportunity because the mechanisms by which you do things are easy to understand and learn, but also the hardware is available on subscription and is also extremely cost effective. You're not spending millions and millions building centralized facilities, for example. And this means that you can distribute capability around a particular city or town. Each individual cluster combines a mechanical recycling capability to take plastic waste, whatever is created, reconstitute it into the consumables, which are then used within the on-demand manufacturing facilities that are then distributed around that very same mechanical recycling hub. Now, this allows the community as a whole to become the factory. Now, this has a couple of advantages. First of all, as we said before, you're not manufacturing it thousands of miles away and relying on them to deliver it from that location to you, which can take anywhere over 6 weeks because you can get your supplies and change your supplies immediately. You are also not using a huge amount of carbon. And the reason why we say that is because the manufacturing devices themselves can operate within the 30 watt to 120 watt range. So you're not even using kilowatts of power. And typically we find that our individual nano devices can deliver the same products for 1/400th of the energy. And while injection molding makes many at once, because those items are then aggregated together, loaded onto a pallet, shipped halfway around the world to then be dropped off in the community they'll be used in, ultimately by desegregating that pallet again, we deliver them at the demand side location. That means at the shop or at the hardware store or even theoretically at the hospitals where it'll actually be used. The machines themselves don't have a spare energy source. They can work off renewables, and crucially, because they're in the same buildings that people are going to be using them in, there's no extra heat source to then have to heat the environment for the workers, etc., because that's already in existence. In essence, it's using the energy or the latent energy that exists in that environment to kind of maintain the working environment, if you like. The only thing it then does do is add a little bit of electricity use while it's being used. But this is a fraction of the energy that the distant manufacturing facilities are operating. Now, what this means is we're making better use of the energy that already exists in communities. We're not specifically going out to create a need for conventional infrastructure, because that infrastructure either already exists or we don't need it. And that means that creates an ability to use automating in places you otherwise would never be able to put a factory and never be able to get supplies. And this is typical of disconnected communities. But all of that can also be tracked through Automating's dashboards, because they understand what each machine cluster is doing, the waste that's being collected, where it is in its cycle, and also the economic activity that it has been generated from that waste collection process, thereby not getting rid of it altogether, but actually giving that back to the community to make something out of. There are a few different cluster configurations, and in fact, you can design your own, basically, in a lot of cases, but some of the typical features we find ourselves using in these configurations include things like airport clusters. Now, in an airport, there are lots and lots and lots of moving parts. There are probably more moving parts in an airport than there are in a hospital. And what you'll find here is that there are particular needs, and this allows us to kind of decentralize or structure our offering to collect waste in airports, possibly even from the shops and cafes that exist in this space. Use that as a way to deliver supporting accessories for many different functions, including facilities, cleaners, for example, fixing things like mop heads or mop handles, possibly fixing little fixes and fittings like parts around the airport, for example, coat hooks or clips, clamps, conduit, for things like wiring. There's lots and lots of different opportunities. All of it from the waste plastic that's collected within the airport itself, which means that the plastic doesn't have to go anywhere or be recycled, especially in high energy intensive applications, because you're using at least some of that as a resource within the airport itself. That substituted for the need to create or collect long or distance manufacturing products, if you like, whether that's directly or indirectly through a distribution of hardware stores or contractors. That's one thing. But also, in addition to that, one of the configurations you'll find is the use of our service appliances, which effectively allow you to create an internal um, monitoring platform of your own. And that means you can effectively create the automated cloud environment, recreate it within your facility. And this can be shared if you wanted it to as well, publicly, but generally will allow you to maintain it in private. And again, these are fractions of the energy there. And another similar facility is the hospital cluster. Again, has the same dedicated service appliance, which allow them to build out the fleet management dashboards that can tie into their supply chain needs and monitoring needs for the stuff that you have to keep disposing of. And this is often includes things like medicines, because medicines have a legacy. In particular, there is the requirement to recertify medications every time you change the packaging. So that means moving away from existing generic plastic packaging might actually be quite difficult. So as a result of that, there has to be a way to deal with that plastic. And you may as well reuse that plastic in-house as a way to create the products that you would otherwise have to buy from, again, places like China, etc. And that includes things like fixtures and fittings, clips, clamps, the same conduit stuff that you would use in airports. As a result of that, you're using the waste internally to then offset the carbon emissions from other parts of the service and other category towers in the case of the NHS. That then allows you to deliver a magnified or amplified benefit as long as, of course, they are procuring for that. Because what typically happens is that they procure in silos. So it often requires a bit of an awareness-raising exercise to explain to hospitals why delivering this cluster-based model can help deliver across multiple category towers. And this does create sometimes a bit of friction in the understanding of the procurement officers. But there is an onus to make things greener, and circular economies like Automedi are a way to do that. So it's definitely worth persevering with that sort of structure. Another place which has a different configuration is townships. Now, these are disconnected communities. These might exist in places like sub-Saharan Africa. They might exist in Democratic Republic of Congo, places like that, which don't necessarily have infrastructure available to them. So they might not have roads. They might not have power infrastructure. So Automedi in that configuration uses a lot of renewable energy sources. So they get plugged into either battery-backed up solar. That together allows the Automedi clusters to work as a unit still, but actually without the need for conventional infrastructure to exist. And that's important because many of the places don't have that infrastructure. And it's no great secret that 51% of the world's population has no access to basic healthcare, in no small part because of the lack of infrastructure to then support the existence of factories, even though they have the knowledge and intellectual capital there. So townships, this is another area, obviously, that's big on it, especially in the area of parts, because sometimes you can get the capital down there, whatever the infrastructure is, but then replacing parts becomes an absolute nightmare. And this can mean that you're losing maybe 8 weeks, 10 weeks, 13 and even 26 weeks of utility because you can't replace parts or you can't repair infrastructure because it's broken. So having the ability to make parts out of waste that often exist in these places because we in the developed world ship it, changing that waste into something that becomes economically useful is an imperative, and Automedi is a way to make that economic value a reality. Another possibly out-of-the-box arena is marine. So using Automedi in rugged environments. Now, this is something we actually went to DASA, the Defence Accelerator in the UK with. Now, they didn't take any interest at the time, but what was interesting was fairly recently the Dutch services have started to look at using 3D printing as a way to make parts on board. Basically, they took our idea, and 2 years later, they've started to try and make it reality. So you can see that as a result of that, the DAS has missed out on a valuable opportunity here. But in essence, the idea of using Automedi on fleets that goes beyond what the Dutch government are currently doing is to effectively use them as a distributed network. So that instead of having to arrange resupplies through a conventional, very high cost, difficult logistical exercise to do it at sea, you basically fish plastic out of the sea that you're going past, or you simply use your own rubbish and then create parts and products on board the ships. And those can also be distributed out when either a marine or land-based exercises come on board. And that means that the facilities also go with them. And that allows them to deliver field hospitals in remote places in much the same way as we've talked about for the previous cluster. So this allows not just military applications, but also other maritime applications to take advantage of automated clusters, and also configure it in such a way that you can deliver a robust, resilient supply chain. Because if, for example, one unit gets taken out for whatever reason, so there's still that ability to resupply itself regardless. And this is one of the benefits of using cluster-based models. If anything goes wrong with one unit, one manufacturing unit especially, you have maybe 99 others that you can quite happily get to without going too far. You're creating a resilient supply chain because if something does go wrong with the individual items, you still have the ability to function because you have other elements and those can be repaired in the meantime. And this is quite a standard assumption, is assuming something will fail somewhere down the line and then also having the ability to recover from that should be quick and easy. And this is really what Automate is about. We have multiple, obviously, operating configurations that work in a hybrid online offline mode, which means that if something does happen to a central cloud server or you lose connection to it, it can still function offline. So all of that has been built into the infrastructure so that if something does go wrong, you still have the ability to get supplies as and when needed. And this all together allows us to deliver a fractal style setup. I mean, in the case of maritime and marine military, in this particular case, you can see that this has a fractal structure where it's got a kind of overarching demand at the top here, where there might be the distributed maritime fleet taking control, if you like, of a central requirement, while it's federated out to what could be a distributed operation. And that means you've got an end-to-end supply line in the conventional sense that starts under your control and continues all under your control all the way at all the individual levels. That means as you get smaller and smaller and smaller, you still have the capability to always go back up to the top if you need to, through a virtual distribution hub, which then allows the coordination, if you like, of all these activities across the entire fleet, one way or the other. And altogether, this allows us to do a number of different things for manufacturers. And in particular, manufacturers who have an interest in doing stuff kind of either short-term or low risk, or even higher risk. Because the infrastructure does allow us to rethink the way manufacturing occurs. And in conventional supply chains, of course, you're typically delivering stuff that's manufactured centrally somewhere else, and then you're either delivering the primary market for the product or you're delivering a secondary market for the parts for those products. But the thing with that is that both of them have the same footprint. Now, what should happen is that at least as a minimum, you should be considering the cost of the transportation, the carbon cost of the transportation, as well as these days the fuel cost of the transportation as well. And by making the products and parts nearer where the customers are, this radically reduces the carbon emissions and also potentially takes out some of these long distance freight systems, which actually have some of the biggest failure rates for many different reasons. They also have a number of different other ethical considerations, such as modern slavery, child labor, and all of that gives you a social value negative impact, which you've got to account for within your procurement often. So if you're trying to supply places like the NHS, a lot of these secondary or social value considerations do become a very, very big factor. And it's now a requirement in the UK at least, under PPN 0621, which is a public procurement notice, to report on carbon reporting, but also consider social value under PPN 0620. Altogether, this means that manufacturers now have new options to deal with this stuff. And not only that, there are ways of taking advantage of potential new markets as well, even though it initially comes down to something which, on the face of it, seems quite negative. Now, what I mean is things like the right to repair law. Now, if you're familiar with that, the European Union passed a right to repair law. Now, that right to repair means customers must have the ability to repair their own products, whatever those products are. So anything new that was created after last year has to have that built in. But this does give manufacturers a bit of a headache. Manufacturers have been battling with counterfeiters for some time. And those counterfeit products are often inferior quality, but also they take value away from the manufacturers and puts them potentially in the hands of plagiarizers and many of the competition. So what has to happen is manufacturers have to be able to close that gap, but traditionally they've been unable to do that without affecting their own bottom line. And this is especially the case because they have their main manufacturing facilities and a supply chain which they've got to maintain. Now, with a tool like Automate, now they're able to manufacture products to spec where customers are and cover their sustainability mandate as well. You now have the ability to create a right to repair outreach factory. In essence, something that can deliver the parts on behalf of the manufacturers to the manufacturing spec, now potentially for the cost of the counterfeit products, right? So what you've now got is a situation where your counterfeiters have no advantage here because the cost is identical, if not less. And also you can market it and take advantage of the brand trust that people have in the service. And that gets rid of this kind of reticence, if you like, from customers to use brand or use dealerships because of the fact that it's still much more expensive. And that premium now in a time of greater cost of living pressures is now completely unjustified for most people. So as a result, it doesn't help customers to maintain the classical separation, if you like, between the counterfeit products or the replica products and the originals. But to deliver the originals requires a service like Automedi, which means that it can cut out that supply chain and also deliver products faster, especially if you're in one of those places where you've got a high value product like a car or something and something breaks on it. And the mechanic says, well, I've got to order a part. It has to come from the manufacturer and it's going to be 2 weeks. And that person is then really put out by that 2 week delay. So these temporary fixes, for example, they might put in, which don't necessarily deliver the right service to the car and can potentially even cause greater damage. So having the ability to create I'll call it a right to repair equivalent, a secondary market, if you like, for parts from many of these thrown away plastics is a crucial potential opportunity there that services like Automedi can give you. Now, overall, this means that the world can move away from these centralized landfill style, large scale services to take away waste and then have a completely separated manufacturing process, because waste now is a raw material. And if we think about it, these raw materials, when put together with the cluster model of Automedi, suddenly allow you to deliver services in many different places, but also maintain your supply chain sovereignty, i.e. within a country you now have a reliable way of ensuring that you can always get supplies regardless of what happens. There's no dependency on a manufacturing facility somewhere else halfway around the world. These cluster-based models create a more resilient, more responsible, but also more opportunistic way of exploring and delivering on supply requirements. But this is often what clusters are about. It's how do we configure and build a mobile, responsive, agile, hardware-based infrastructure system. How do we do that? And clusters are a way to do that by clustering together fleets of stuff together with the back end processing to give you that full cycle circularity, but then replicate this through a simple cookie cutter approach. That means that you might have maybe a dozen different clusters within a city as a minimum, a small city, but a large city might have maybe 3 or 4 dozen clusters. And that gives communities the ability to work within that space and creates jobs in that community as well, instead of outsourcing that to another part of the world and then having to create or ensure a supply chain resilience in something which has too many moving parts to ever be as resilient as something like Automedi could be. This has basically been a quick tour about clusters and explain why they exist and what their benefits are, especially with the technology that we're delivering. If you want to know more about clusters, obviously get in touch. If you want to know more about how Automedi can help your organization, do get in touch about that too. Thanks so much, everybody. Have a great day.